In today's note, we're going to be looking at ions. So just a reminder, in order to understand how to create ions, we have to be really good or have a really good understanding of how to draw Bohr-Rutherford diagrams. This doesn't mean that this is the only way or the only requirement to be creating ions or being able to represent ions, but this is a very good fail-safe if we don't understand or we can't recognize the patterns in the periodic table. So just as a reminder, to draw a Bohr-Rutherford diagram, you place electrons in the shells around the nucleus. A reminder that we have to fill the shell before we move on to the next, and the shell capacities go 2 electrons, 8 electrons, 8 electrons, and so on. We also should remember that the number of electrons in a neutral atom is equal to the number of protons, which is equal to the atomic number. So remember, that's for a neutral atom. Ions are considered charged molecules or charged atoms, and this means that the number of protons will not be equal to the number of electrons. So for a charged molecule, the number of electrons do not equal the number of protons. So how do we figure out what number of electrons our ions have? Well, we have to use either our octet rule or in some cases our duet rule. So remember, our octet rule is that an atom is only stable if it has a full valence shell of 8 electrons, and our duet rule states that an atom is only stable if it contains a full valence shell of 2 electrons. So depending on what element we're dealing with, we may have to follow the octet rule, or we may have to follow the duet rule. So let's look at lithium. Lithium has an atomic number of 3. This means in its neutral atom, it will contain 3 electrons and 3 protons. So if I draw this, it's going to look something like this in terms of its Bohr-Rutherford diagram. So we have our positive core, and then we have 3 electrons orbiting around it. We have 2 electrons in that first shell, and then our third electron we're going to place in the next shell. So if I look at lithium's valence shell, that means, or the outside shell, I can tell that it's not full. There should be 8 electrons in there if it was full. However, it's not. It only has 1 electron. So in order for that outermost shell to be stable, how many electrons does it want to have? Well, based on our shell capacities and our general rule, it wants to have a total of 8 electrons in that outer shell in order for it to be stable. So we have to think now, in order for this outer shell to be stable in this lithium atom, is it easier to add 7 electrons to that outer shell, or if I go back to the original, is it easier to just lose that 1 electron? While I don't have 8 anymore, I still have a stable outer shell because that first shell only requires 2 electrons. So we have to think, is it going to be easier for lithium to gain 7 or lose 1? Even in just terms of common sense, if you think about the energy that would be required to lose 1 or gain 7, it's easier to lose 1 electron. So that means if lithium lost 1 electron, it would look something like this. Just the 2 electrons in its first shell, and it would have an overall charge of +1. So that means we would write it as lithium +1, or Li with just a positive. So that would be our lithium atom. Our lithium ion. In another example, let's look at oxygen. So oxygen has an atomic number of 8. This means in its neutral atom, it will have 8 electrons and 8 protons. So if I draw that, there's 2 in the outer shell, and there are 2 in its first shell, and then 8 or 6 in its outer shell for a total of 8. Again, if I look at oxygen's valence shell, or its outside shell, I can see that its outside shell is not full. Right? It wants to have a total of 8 electrons in its outer shell. So again, it has 6 in its outer shell, but to be stable, it wants to have a total of 8, which means it wants to get to a total of 8 electrons. So the next part of this, in order to create an ion, I need to make that outer shell stable. So I have to think, is that outer shell going to be stable by adding 2 electrons or by losing 6 electrons? So is it easier to add the 2 electrons here, or is it easier just to get rid of all of them and be left with 2 in my first shell, which would still be a complete shell? But in terms of energy and in terms of common sense, is it easier or better to gain 2 or lose 6? Well, in terms of common sense, it's easier to gain 2 electrons. So it's easier to gain 2 electrons, so that means that our oxygen ion would look something like this. Let me just use a different color actually to represent the 2 electrons that are added. And I'm going to put brackets around my diagram. And it has, not 2 plus, it's 2 negative or negative 2. So that means it's oxygen with the 2 negative charge because we've gained 2 negatives. So that means that oxygen, the oxygen ion, has a charge of negative 2. So for some practice, go through your periodic table for the first 20 and draw the Bohr-Rutherford diagrams for each element, right? Similar to our quiz. So draw each neutral atom, so based on the atomic number, and then based on your knowledge of your 2 rules, is it going to be easier for your element to gain electrons or lose them to complete an outer, or to fill its outer shell? And based on that, then draw in what your ion would look like and write the charge for each element if it was an ion.